Hi, and welcome to Lesson 3.2, Rotations. So last lesson, we looked at the ideas of arcs and angles and measuring different angles. Now this lesson, we are going to look at the idea of rotations or rotating points or figures. So a rotation is a turn about a fixed point. So counterclockwise rotation, we always consider to be positive. So if I considered looking at the circle down here, O being my fixed point, and if I took point F and moved it counterclockwise, that would be a positive rotation. If I took F and moved it clockwise, that would be a negative rotation. So rotations are if we keep the set point, our fixed point in the same spot, and we rotate a figure or a point around that based on the number of degrees. Counterclockwise positive, clockwise negative. And then when we're measuring our rotations, we measure them based on degrees, the angles, and the arcs. So in example 1, it says in the figure at the right, the dashed ray OH represents the direction a fox is facing. So the fox is facing O to H, this ray here. If the fox's field of vision is 85 degrees, how much of a turn is necessary so the fox can see something directly behind him? So the fox's field of vision is 85 degrees. So that means that whole arc where he could see is 85 degrees. So the fox could see to point F and to point X, 42.5 degrees on each side of point H. So this arc, Fx, is the fox's field of vision, or angle FOX is the fox. So what we need to think about is we need to move point X here along the circle to be directly 180 degrees behind the fox. So we're moving X from here all the way here so it's behind the fox. Now these little hash marks, the apostrophes by the letters, so X apostrophe, H apostrophe, F apostrophe, those read as X prime, H prime, F prime. And what that means is if X is originally here, X prime is going to be the final point where X ends up. If F is here, F will end up at F prime. H is here, H will end up at H prime. So those are the new locations of F, X, and H. Now what I know is 180 degrees would be directly behind the fox, or a semicircle. So if I take the 180 degrees from H to X prime, our semicircle, and I subtract the 42.5 degrees that the fox can already see, I'll be able to tell how much further I need to rotate X. And how much further do I need to rotate X? It needs to rotate 137.5 degrees. And we're going clockwise, so it would be a negative. So that fox would have to rotate a negative 137.5 degrees. And that would change the field of vision so that it could see something directly behind it. So now that fox could see from F prime to X prime, which allows it to see something directly behind where its original stance was. Now, when we are rotating a figure, a point, a shape, whatever it may be, the original figure, the original location or point, is called the pre-image. Pre meaning before. So pre-image is the original. The final figure, final shape is known as the image. So pre-image is the original, the new or final figure is the image. Now, in example 2, it says pentagon, P prime, E prime, N prime, T prime, and this should be an A prime. So our image has all the primes, meaning it's our new location. So the penta with the apostrophes is the image of our regular penta under a rotation about center point G. What is the magnitude of the rotation? Now, the word magnitude just means how many degrees did we rotate that image. So however many degrees your rotation measures, that is the magnitude. And then you just have to decide if it's a negative or positive. Now, they gave us the image over here. The first thing you would do if it was not provided for you, so if all we had was point G, our original pre-image, and our final image, you would want to start by picking any point off the image and its corresponding point on the pre-image. So I'm using A and A prime. From point G, we draw the rays so that we create GA and G prime, or GA prime. What that allows us to do is to create an angle. Now I can measure, using point G as the vertex, I can measure angle AGA prime. When I do that, I get a measure of 65 degrees. Now, if you're not sure how to use the protractors to measure, please come see me. It's a very quick process. I can remind you or refresh you on how to use a protractor. So we know it's a 65-degree angle. Now, the angle measure is the magnitude. So the last thing we need to figure out is if it went positive or negative direction. So from our original to our new, that's a positive direction. So it would be a negative 65 degrees. So our magnitude is a negative 65 degrees. Now, the notation of that. If we ever see this type of notation, this would read as the capital R is rotation of. What's in the parentheses is what we're rotating, and the magnitude goes down here in the sublettering or subscript. So this would be the rotation of pentagon, PENTA, of a magnitude of negative 65 degrees. And then we get into example 3. So in example 3, it says there's 12 notes on a piano that are placed on the circle shown at the right. So all of our notes are here. A sharp, B, C, C sharp, D, D sharp, E, F, F sharp, G, and G sharp. So all of our notes equally spaced around a circle. Now what it says is the notes of a C major chord are represented by the vertices of the triangle CEG. So our C major was C to E to G. So this triangle here is our C major notes. To find the notes of the other major chords, we can rotate that triangle clockwise about the center of circle O. Name the notes of a D sharp major chord. So they gave us the C major chord. So now I want to get to a D sharp major chord. So in this case, I'm going from the C major to a D sharp major. So I'll be rotating C, E, G so that C matches up with the D sharp. So I move point C 1, 2, 3 clockwise points. So then I'm going to take point E and move it 1, 2, 3 clockwise points. And then G from my original triangle, rotate it 1, 2, 3 clockwise points. So now my new endpoints for the D sharp major would be D sharp, G, and A sharp. So the notes in this case for the D sharp major chord would be D sharp, G, and A sharp. So with the rotations, there's not a ton of notes to take because part of the process is going to be you going through and actually doing some of these rotation drawings and measuring arcs or angles. So if you need help at all during this practice problem set, please feel free to come ask. I'll show you step by step the process for drawing figures and how to properly rotate them. But the idea goes back to this idea here of drawing in the rays to corresponding parts so you can measure the angle and then move the other points as need be.